Welcome to 205B Part 2 on services and service equipment for single dwellings. We're going to look at objective number 3, which is service protection and control equipment, and all the rules that go into where and how to place these. Where we place our service equipment is very important because we need to be able to work on it comfortably and safely, and we need to make sure that there's enough access to be able to get to it. So there's a few different rules we have to look at. First of all, let's look at Rule 6206, which states that wherever we put our equipment has to be approved by the supply authority. So whoever is supplying the power to the building has a say on where we put our equipment. Rule 226 also states that the inspector has power of rejection if they're not happy. So not only do we need to make sure that the supply authority is happy, we need to make sure the inspection department is happy as well. Normally, this is achieved when we submit our drawings into the city or the supply authority for approval in the first place. A few other things we need to think about is it must be readily accessible. It has to be located as close as practicable to where the conductor enters the building. Standdata actually limits the length of the service conductor to 3 meters from where it enters the building to where it enters the service box. If we can't make that happen, we can go up to 7.5 meters, but then we have to protect it with rigid steel conduit. Some of the other undesirable locations to think about is things like closets, bathrooms, stairwells, or anything else that's considered to be dangerous or hazardous locations. So think about it this way. If you don't want to work there, don't put the panel there. We also need to make sure that if any rooms are going to be hotter than 30-degree ambient temperature, that's not a good place for service equipment and it's not allowed. Also be aware of the flood zones inside your city because that changes how we install our service boxes as well. Rule 26600 states that when we locate our panel boards, once again, don't put it in any undesirable locations, but we also need to mount them as high as we can, but we cannot exceed 1.7 meters to the top overcurrent device handle. So if we're going to put in our panel with our service box on top, our service disconnect breaker cannot be more than 1.7 meters. If we're going to flip our panel upside down, because we're going to bring our service conductors into the bottom of the panel instead, then the top available space for a breaker cannot be any more than 1.7 meters. Rule 2308, we already discussed it a little bit when we talked about meter bases, but we need to make sure that we also maintain a minimum of a 1 meter clearance in front of the panel. Something that you'll see a lot in residential is that people will tend to put their laundry equipment right in front of where the panel goes, and that's not allowed at all. We need to make sure that we have stable footing so we can properly work on it without any hazard to us. You'll also notice that a lot of places tend to store a lot of things right in front of the panel, and we have to warn our customers not to do that. If we need to be able to shut off a breaker in a case of an emergency, that storage is going to make sure that we can't get there fast enough. Let's take a closer look at Rule 6206, Subrule 1V, which states that we cannot locate our service box in any areas that are below the floodplain elevation. Places like Medicine Hat tend to flood every once in a while, and the City of Medicine Hat actually has a flood elevation map available on their website that tells you what the elevation of that flood zone is going to be. We have to make sure that wherever our service boxes go are not below that floodplain elevation. What we can typically do is use a combination meter base. This will have the meter base on top and a service box directly below it, and we can mount this on the exterior of the building to make sure that our service box is not below the floodplain elevation. This way, in case of a flood, we can easily turn off the service box without having to go into the basement and risk ourselves. When it comes to the rating of our service equipment, we have to be aware of a couple different things. First of all, we already discussed about how to use Rule 8200 to size our service conductor, and then we use our service conductor ampacity to select our overcurrent device. We would also be using our service conductor ampacity to select our service equipment ratings. When it comes to a combination panel board, the bus bars inside that panel board are considered to be an extension of the consumer service conductors. So therefore, their ampacity cannot be any less than the ampacity of the conductors themselves. It's interesting to note that most 100 amp panels have bus bars that are rated at 125 amps in order to facilitate this rule. Now that we looked at where we can place our service equipment, we're going to look at two different styles of services and what rules affect them. Overhead services are supplied from a transformer mounted on a pole, and the supply service will go through the air to connect to the consumer service. There are times where we can transition from a pole service to an underground service, but it's not always feasible and it's usually an extra cost. The main concern that we have with an overhead service is maintaining a safe clearance for the conductors. We have to pay attention to Rule 6112 Sub-Rule 2, which gives us some of the rules based on where to put the point of attachment compared to where we're going to put the service head. 6112 states that the service conductors shall be attached to the building on the same side as where the service head is. So we can't be mounting it around the corner in case of an unmasted service. We also have to make sure that it is placed in such a way that the service conductors will run away from the building on an angle. So we cannot go over the corner of a building. And once again, it must be in compliance with the supply authority. Sub-Rule 3 deals with how much clearance we need to have between the cables themselves and the ground. And this all depends on what is going underneath the cables. So depending on what kind of vehicular traffic we have or what kind of obstacles could be found underneath it, it will change how much room that we need to have for clearance. For example, for highways, streets, and accesses, that's the most clearance we're going to need at 5.5 meters, whereas pedestrian walkway would need the least amount of clearance at 3.5 meters. So all depending on what your service is going to go over will change the amount of room that's required between the ground and the conductors themselves. These measurements all affect how high the point of attachment needs to be from the ground. There's two types of overhead services that we can do. And the first type is called a masted service. We would use a masted service in case our service raceway ever has to go through a roof in order to meet the height requirements of Rule 6112 Sub-Rule 3. The code book states that the raceway that we use in this condition must be a rigid steel metal made of at least a trade size 63. The reason that we want to use rigid steel conduit is because we want to have that physical strength so that it can hold not only the weight of the conductors themselves, but any forces or load that are put on those conductors. The Standata allows us to use smaller than trade size 63 depending on the conditions of the installation. Remember that Standata is only used in Alberta, and it's because of environmental conditions in Alberta being different than other places like Ontario that we can actually have a smaller conduit size. So Standata states that depending on how high we are going from our point of attachment to our roof line will change the size of the requirements for our rigid steel conduit. The higher we go, the larger our conduit has to be. We need to make sure that our masted services are solidly secured to the building. That means they have to be bolted through a piece of structure that's at least 38 millimeters thick. We could put in a 2x4 in order to support our mast, but that 2x4 must be part of the structure. We also need to make sure that we have 3 separate support clamps securing our mast. One right below the roof line, one right above the meter base, and then one between those 2 points. Make sure you're checking Appendix B on this rule to see all the different components that are required for a masted service. The other type of overhead service that we have is an unmasted service. And this is where the height requirements do not require us to go through a roof line. We can bolt everything directly to the side of the wall of the building itself. This changes how we do a few things. First of all, our point of attachment is now going to be directly to the structure and not to our raceway like it was with our masted service. Secondly, our raceway has more options. Instead of using a rigid steel conduit, we can use whatever we need as long as it provides mechanical protection for our conductors. We can use PVC, we can use tech cable, we can even use an EMT as long as it's rated for our area. Rule 6306 also states that we need to have a minimum raceway size of trade size 21, which is a 3/4 inch conduit. This is because we don't need to worry about holding up that extra weight of the conductors because now that's being held by the structure itself. When it comes to the service head on an overhead service, there's a few different rules we need to be aware of. Check out Rule 6114. It states that the supply and the consumer service shall be equipped with a service head that is suitable for use in a wet location. The weather head is installed to make sure that there's no water that can get into our meter base due to rain or snow. Rule 6114 Sub-Rule 4 also states that each conductor of a separate polarity needs to go through their own hole. So the weather heads actually have a bush cover with knockouts in it. In the case of a residential service, we would knock out 3 of the knockouts in order to facilitate 1 conductor per hole. Rule 6116 deals with how far away the point of attachment can be from the weather head. It states that it must be within 150 millimeters to 300 millimeters vertically to the weather head. That makes sure that the point of attachment is below the weather head, not above it, and we can't be too close and we can't be too far. The other rule that this rule states is that we cannot be too far side to side from our service head neither. So our point of attachment cannot be any further than 600 millimeters left to right of the service head as well. So if we're going to go with an unmasted service where we are attaching the point of attachment to the wall, we have to make sure that we're not too far away from the service head. Lastly, Rule 6302 states that we need to leave at least 750 millimeters of wire coming out of the service head as well. This is for two reasons. First of all, we want to make sure that we have enough wire there to facilitate a connection from the supply authority. And secondly, we want to make sure that there's enough wire there that we can put in drip loops. We want to make sure that in the case of driving wind and rain, any water comes down and drops off the drip loop rather than being forced up and into the weatherhead. The last thing we need to think about as far as clearances are concerned is Rule 6112, which states that we need to make sure there's at least a meter of clearance between any access points such as doors, windows, movable awnings and signs, or decks and patios so that no one can accidentally hit the service conductors. Now that we looked at overhead services, let's look at the option. The other option we have is an underground service. Underground services are preferred for a number of different reasons. They need less maintenance because they're not exposed to the elements. They're generally safer because no one's going to accidentally run into them. And they're cleaner looking, so we don't have to look at a lot of overhead conductors. Our underground services need to look at two different areas within the codebook. First of all, Section 6, specifically for our service conductors, and also Section 12 for any type of underground installations. Rule 6300 states that for underground service conductors, they must either be installed in a rigid PVC conduit or they must be of an approved cable as per Table 19. This is going to be either a TEC cable or a USB cable. Rule 1212 also specifies other requirements for underground installations. And they state that direct buried cables must meet the depth requirements of Table 53. Table 53 looks at different requirements based on different conditions. The two different requirements that we need to know to use this table is what is our voltage going to be and what kind of conditions are over top our underground line. The difference is for vehicular areas or non-vehicular areas. So things like driveways and alleyways would have a deeper burial depth than any pedestrian walkways would. The reason for this is there's a lot more ground pressure put on because of the vehicles, which could potentially damage our cables. Table 53 lets us know how deep our cables have to be. If, for example, we're going to install our cable in a non-vehicular area, and we're going to use a USB cable which does not have an armoring on it, we must go at least 600 millimeters below the ground. If we're going to use a TEC cable or a PVC conduit, then we only need to achieve a 450 millimeter depth. Rule 1212 also states that if we cannot achieve the depths as per Table 53, we can reduce it by up to 150 millimeters by providing extra mechanical protection. This would be done by either having at least a 38 millimeter treated board over top of your conductor or by having a 100 millimeters of concrete poured or placed over top of your conductors. Both of these methods would provide extra mechanical protection to protect our wires. Subrule number 4 also states that we need to make sure that whenever we're putting more than one conductor into the ground, we need to make sure they don't cross over top of each other. Otherwise, they could produce a pinch point, which would damage our cables and potentially cause a short. The last thing we need to notice is that all of our underground conductors must be surrounded by sand. We need to have at least 75 millimeters of sand below and above our cables in order to make sure that our cables are not subject to any damage from sharp rocks or anything else that may be left in the trench. There's two other things we need to know about our underground service raceways. First of all, they must be provided with adequate drainage. So if water does get into the conduit, it also has a chance to get out of the conduit as well. The second thing is, anytime that we come up and into a house, we have to protect the house from any underground gases that might be traveling along with our raceway. So we are to use a sealant material such as duct seal to make sure that we prevent any gases from getting into the building. We don't care about things getting out of the building. We don't want any underground gases getting into the building. Whether we are running a single cable or if we're running multiple conductors, we need to make sure that all the gaps and spaces around and between the conductors are all filled completely to stop any gases from getting in. Rule 6206 states that any service equipment needs to be placed as close as practicable to the service entry point, but that's not always possible. If, for example, we have a panel that's in the middle of our basement and exceeds the 3-meter rule that Standata allows us, we can run it either underneath the basement slab or inside a crawl space, as long as we meet the conditions of Rule 6208. Rule 6208 states that if we're going to run it underneath a slab, then our raceway needs to be fully encased in concrete, 50 millimeters on all sides. Or we direct bury it in accordance with Rule 6300 and make sure there's at least 2 inches of concrete on top of it. Our other option is to run it inside a crawl space. However, that crawl space must be no greater than 1.8 meters. It cannot be of combustible construction, so no wood construction, and it cannot be used for storage of any combustible items. So be aware of those rules anytime that you need to come into the center of a building. You've reached the end of 205B Part 2, so make sure you are reviewing the modules, going through the Blackboard questions, and whenever you're ready, continue on to 205C.